Okay, now we are at question 19. I hope you have tried it. So, okay, question 19, right, you see that it's again an identity question. Now you have 3 sine square z minus 5 cos z equals to 5. I won't be able to do this question because there's a sine and there's a cos, and there is no way I can factorize this. So the only way to do it is to either change all sine to cosine or all cosines to sine. For this case, which is easier, I hope you can see, because sine square z is actually one of the identity, so it's easier to actually change sine square z to something related to cos instead. So which identity are you using? 1, 2, or 3? I hope obviously you can see that we will be using identity number 1. Okay, so before we do anything, of course, we will look at the range first. This is z only, so my range is only for 0 degree to 360 degree here. So do take note that my calculator should be in degree mode. So remember, calculator degree mode, this is in radian. So I'll do my setup, 0 and 0 to get degree mode. Okay, so before I move on, okay, now I move on next. So similarly, we will just do, okay, I'll just write down the question, 3 sine squared z minus 5 cosine z is equals to 5. So what I need to do is to just change my sine squared to something else. So what do I change to? Okay, the identity, if you were to look at it, if I want to make sine squared z the subject, it will be 1 minus cosine squared z, which means what I write here will be 1 minus cosine squared z. Okay, and from there, I'll just copy the rest in, get the answer. Okay, I'm going to do it slowly, so I'll just open up my bracket to do my expansion, and I'll write it this way instead. Okay, to make it easier to factorize, right now we have all cos already, so it's easier to have a positive cosine. So let's just say bring everything to the right hand side. We will have 3 cosine squared z plus 5 cosine z. With 3, I bring it over to the other side, it will be 5 minus 3, which give me 2 equals to 0. Okay, so now, doesn't this look like a quadratic equation where you can actually do your factorization? So by now, you should be quite good at doing a zero product for this. Okay, so what you will be doing will be just to do factorizing. So if you do it using the mental sum method, one of it will be 3 cos z, one will be cos z. So the other combination for 2 is 2 and 1 or 1 and 2. And in order to get 5 cos z, and it's a positive, so I will put it this way. So here you'll get 3 cosine z plus 2 cosine z to get 5 cosine z. This is just factorization, so I will harp on more. Okay, now we have our zero product. So with zero product itself, I'll be able to split it up to 2 different equations. I can say that 3 cos z plus 2 is equals to 0, or cosine z plus 1 is equals to 0. Okay, and remember, we want to find reference angle, we need to make cos z the subject then. So for this case, cos z is just equals to negative 2/3. And my cos z here will just be equals to negative 1. Okay, so now with this, what do I do? Of course, I still want to find my reference angle, right? So the reference angle will be equals to cosine inverse of, remember, the positive value. So cosine inverse 2/3. Okay, let's just try to complete the first part first before we move on to the second equation. So that will be easier for our calculator. So here by itself, I'll click on cosine inverse. Cosine inverse 2/3. Is it in degree mode? Okay, yes. So answer I'll get will be 48.1897. 1897. Degree. Do you remember our degree? And then the next thing is this. Once I have my reference angle, what is the usual step you do? You'll find your ASTC. Oh, before I do that, let's just store my memory first, just in case I forget. Okay, then the next step, we will just find our quadrant. So same thing. Oops. ASTC. Okay, so which quadrant will actually give you a cosine value that is negative? So hopefully you can see it's your second and third quadrant. And for second and third quadrant, it's simply just 180 minus reference angle and 180 plus a reference angle. Okay, so now here, same thing. So I have the value of z is equals to answer in my second quadrant and answer in my third quadrant. Same thing, there's no manipulation after z. I mean, z is just z. I don't need to divide by 2 or times 2 or anything, right? So what I'll do is I can leave my answer straight to 1 dp. Okay, so my answer is in the second quadrant. So I'll take 180 minus recall memory. And I'll just leave it as 131.8 degree. 1.8 degree. For my second answer, it will be 180 plus my memory, right? For being a bit lazy, I'll just change this to plus. So here I'll get 228.2. So it's 228.2 degree. Okay, so that will be my first part. Is that all? Don't forget, I have another part here. So same thing, I have to find my reference angle for this case, which means I need to do cosine inverse of a positive 1. And cosine inverse positive 1 is just equals to cosine inverse positive 1. It gives me the answer 0. So it's just 0 degree. Okay, so same way we'll do our ASTC again. ASTC. In order for my cosine to be a negative value, which quadrant would it be? Negative value. So it will be the second and third quadrant. So similarly, I have my 180 minus reference angle or 180 plus reference angle here. Exactly the same step. The next step is just z is equals to my second and my third quadrant. So second quadrant, 180 minus 0 degree. This one quite straightforward, 180. Similarly, 180 plus 0 degree. Okay, I still get like this. I just need to write one of them. Okay, so final answer. We know that its answer is only within 0 to 360, so I don't need to go one more cycle. Final answer, since there are so many parts of it, I have to arrange my answer in ascending order. So it will be 131.8 degree, 180 degree, followed by 228.2 degree, and that's your final answer. Is that easy? So all the steps that we are doing is exactly the same. Just try again, and then you can try on your own question 20. Question 20 also requires the use of identity, but it might require a bit more, it's still the same, but it might include a bit of substitution method. Okay, with this, please do your work first.